All right, here we are for Honors Physics Electrostatics, Worksheet 3, looking at Coulomb's Law calculations. We're going to take a look at problem 7. Problem 7 says, suppose the two people in the previous problem move towards each other. Calculate the magnitude of the electrical force of them on each other when their separation is reduced by a factor of 10. This is very much like a problem we did earlier, like problem 2, where we were taking our Coulomb's Law equation and we were changing the value of one of the variables and seeing what effect it had on another one. So we're going to solve it by that same technique. So we're going to start by taking a look at Coulomb's Law. And say, okay, my electric force is equal to the Coulomb's Law constant times the charge of the first object, charge of the second object divided by the separation distance squared. And you say, okay, what's the change that we're making here? You say, well, the change is we're going to take that separation distance and we're going to make it 1/10 as big. So instead of squaring r, I'm going to be squaring a value that is 1/10 of r. Now, if I make that change on this side, you say, well, look, the Coulomb's Law constant, it's a constant. It's not going to change. We're not changing the charges on the two people. We're just changing their separation. So I made a change here. I got to balance that out to keep the two sides equal. You say, these aren't changing. Fe must change then to keep the sides equal. What's the change I'm doing? I'm putting a 1/10 in the bottom that's going to get squared. So over here, I have to put a 1/10 in the bottom and square it. All right. You say, okay, that means I'm going to have, on the left side, I'll have Fe, and you say a 1/10 squared, that's 1/100th. And you say, okay, when I divide by a fraction, I can multiply by the reciprocal. So it'll be 100 times that original force. Okay, it's going to be my new force. When I solved the previous problem, I just did like an order of magnitude estimate. And I said, oh, that comes out to be about 10 to the -1 newtons. Is that right? 10 to the -1. But when I guess Wishway, when I looked at the solution, Wishway had actually gone through and calculated it. I think he got an answer of like 0.4 newtons. And so you say, okay, well, it's going to be 100 times bigger than 0.4. That would be 40 newtons. Okay, is what that new value would be. All right, and so that is question 7.